My name is Ben Wycliffe. I'm going to be talking about exploratory data analysis for one of the datasets we're working with in the project titled Using Machine Learning to Predict the Likelihood and Cause of Customer Churn in Retail Banking. So our dataset includes 14 columns and 10,000 rows. The columns include the row number and customer ID, which uniquely represent a particular data point or row. And then they include the surname, the geography in terms of the country where the person is located, their credit score, their agenda, how old they are, how long they've been with the bank, their bank balance, the number of products they subscribe to, whether or not they have a credit card, whether or not they are an active member, their estimated salary, and whether or not they exited the bank. So at first glance, this is what the dataset looks like. So from looking at this, we can tell that the row number, customer ID, and surname do not qualify as features because these, especially the row number and the customer ID, they are unique in the dataset and they wouldn't give us any information for our model to learn from in terms of patterns. And then we can see that the exited variable is our predictor variable because it specifies whether or not the customer churns. And then we have a number of categorical variables, and these include the geography, the gender, as well as the number, whether or not the customer has a credit card, whether they are an active member or not. So the first thing we did was to do an assessment of our predictor variable, just to get an idea of how many data points.
The Bluetooth device is ready to pair.
Just to get an idea of how many data points are be associated with every class. And from this we see that there's a very huge class imbalance. We have over 6,000 more data points associated with those customers that are still with the bank as compared to data points for the people that churn. Then next we did an assessment of the data distribution based on the gender category, whether the gender data point. So we did this for some of these categorical variables we had in our database, and gender was one of them. So from this we can deduce that our data set is not biased towards any particular gender. We see that there's quite some balance in terms of the distribution of data points with every feature for both genders. We also see that there's a few outliers, but these are common for both genders. And then we also did the same thing with geography again to get an idea of what the data distribution is across the entire data set based on geography, and it's the same idea. We see that the distribution for the different categories, i.e. the countries, is somewhat balanced. So we see again, especially with age, we have these outliers here, which definitely will give us some information. But at least for starters, we see that they're almost equally distributed among all the geographic categories. And yeah, for the most part, our data set is not biased toward a particular country in terms of spread. So that is a good sign. And then lastly, the most important data distribution analysis was on the exited data point, the exited column, i.e. the column that we associate with whether or not a customer churns. So this sort of gives us an idea of how data is distributed in relationship to the categorical variable that at the end of the day we shall be using to perform the classification. So we can see here that now things have changed a bit. We see, especially for age, we see that there's almost a clear distinction, and we can tell that people that are much younger are the ones that the people that stay with the bank are either much younger or much older. So most of the people within the middle age group actually leave the bank. So this is some important information to pick. And then we also see that with credit score in particular, we had outliers associated with people that are leaving the bank, and these outliers are those extremely low credit scores. So it sort of makes sense, people that have extremely low credit scores leaving the bank. And also looking at the medians in our box plots, we see that okay, for each box plot, we see that okay, there's a clear distinction between people that are churning and people that do not churn. See that the median is almost lower for the people that are leaving the bank in terms of bank balance, and then higher for people that lower for the people that are staying with the bank, and then higher for the people that leave the bank. And this probably implies that it's mostly the people that have more money that are most likely to leave. Same with the estimated salary. You see that again, people that have a slightly higher estimated salary are the ones that are more likely to leave the bank. So after doing this, looking at the tenure and the estimated salary, we see that the density functions almost have similar profiles. So we went ahead to assess them independently to see whether they do not have any form of correlation or whatsoever. And yeah, this was the result. The scatter plot shows that these two features do not have any sort of correlation. So it's probably important to include both of them in our modeling. And then further to make more sense out of the age scenario, we plotted an unstandardized box plot of age to see exactly what's happening here, and we can see that it's mostly the people between the ages 50 and around 40 that leave the bank, and then the younger ones between 30 and 40, and also the very old ones are now the ones that stay with the bank. So we did like a pairwise scatter plot to sort of do some assessment of the feature independence, and yeah, from this plot we see that features from the scatter plots we see that there's no particular feature that is correlating with any other feature, which is a good sign in terms of the importance of each of these features. And then we complemented that by visualizing the correlation maps. So we can see that these features are almost only correlating with themselves, and the correlation scores when we compare them with other features are relatively low. So there's a very low correlation score between different features, meaning that our features are most probably all important to include in this in the modeling. Then one of the interesting patterns that came out was when we were trying to assess the different features by plotting them in terms of count. We noticed that for the number of products feature, especially people that subscribe to a higher to more products are more likely to leave. So we see that all the people that are subscribed to at least 4 products left the bank, and most of the people that subscribe to at least to at least 3 products also left the bank. So this is plotted on the same scale. So unfortunately, again, as we saw from the start that our data set was imbalanced, we see that most of the people that have we see that we have a relatively smaller number of people that subscribe to either 3 or 4 products, But again, this makes sense since we saw that there's a class imbalance, so it makes sense to see that if someone has subscribed to more products, they leave the bank, but then we have less data points for that. Then lastly, we try to do the pairwise plots while doing some sort of clustering to show the differences between the people that leave the bank and those that stay with the bank. And so from this we deduced that with the introduction of the age feature sort of gives us more information when combined with these other features here. So it's the age feature and the number of products. So we see that for other scenarios, for example, when we combine balance and the other things, we see there's not a lot of information to pick from there. But we see that when we combine age with all these other features, including balance, credit score, and estimated salary, we have like some sort of clear distinguishing. We see that most of the people that actually leave the bank are situated along the center of the cluster, which signifies potentially some important features to pick, or some important information to pick, especially when we have age along these other features, and same as number of products. Yeah, so in conclusion, only 11 of the features that we have in the dataset appear to be useful for Chan, and then we did not have any missing values in this dataset, and then age and number of products seem to be like the most useful features. We also noted that the feature values have to be standardized in order to reduce variance in our modeling. So we developed some sample model, and again the features were as follows. So we did split the datasets into 70% train and 30% test. We used the standard scaler from scikit-learn to standardize the feature values such that we're constructing them within a similar range. And we tried out for starters. We tried a few models for the starters, and AdaBoost was one of them. And with this, we got 86% accuracy. So these were the results from the classification report. So as we can see, the accuracy was 86%, but it's almost evident that the model was doing much better with the other class, the class of the people, the class associated with the people that stay with the bank, and then worse with people that churn. And to us, this goes back to the fact that there was a huge class imbalance, which we did not address for starters. So we are pretty confident that if we address this class imbalance issue using some of the recommended techniques in machine learning, there will be a significant improvement in the classification of the people that churn. Thank you.